Howdy, seventh period. I'm gone seventh period because I'm taking the flag football team to driving the van to their tournament. And even though I was here earlier in the day, you might have seen me. I don't know. But this is what we're doing. You have stuff you can do in class, and hopefully you don't have any homework. I'm not sure how long it will take you, but if you lock it in, you can get through this stuff pretty quickly. I'm gonna talk you through it, but all the notes are there for you. So I'm not going to handwrite any notes today. You're going to just be able to see them, and they're on the agenda. So if you go to the agenda, you can basically follow these instructions and do this stuff. So we have a Sparky quiz, CK12 bookwork, and a one pager if not done, and the Gizmo you should do as well, obviously. So I'll take you through one step at a time. So first of all, we have a question about Usain Bolt. He's the world record holder in the 100 meter, and he ran it 100 meters in 9.58 seconds, as you can see them, him posing next to the sign. How fast is he running the 100 meters? And what if he could run that way the whole way to John and Bon's yogurt? How long would it take him? Take a guess. Like if you were sprinting as fast as Usain Bolt from here to John and Bon's yogurt, how many minutes would it take you? Now, we talked about walking, and if we walk there, it would take like 40 minutes, right? But at that speed, how fast would he go? So let's work through that problem. So right here is where the notes for that are. So get out your paper and your pencil, and let's take some notes on that stuff. So this is called 5 steps, and the 5 steps to solution are going to ask you to do this stuff, right? And so it says 5 steps to a physics solution. That stupid bar keeps coming back, but I can't get it to stay away. That's kind of a pain. But here are the 5 steps: 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then down here, I'm doing it without numbering it. Okay. So up here, 1, setup. Draw a diagram, or you can do a known and unknown chart. But I would rather you put the knowns and unknowns on the drawing, not on the chart like this. This chart, some people like it, but it's better on the drawing because it gives you more information because it's on the drawing itself. I would say drawing. 95% of you should do the drawing, and then stubborn people might do the chart, but the drawing's better. Okay, so he's going 100 meters in 9.58 seconds. We knew that from the warm-up. How fast was he running? Okay, so number 1 is setup. I have all my variables. I know my units. I know how to identify this stuff. I'm ready to go to an equation now. Step number 2, I'm going to write the equation. I can make a choice. This one isn't already solved for V, but this one is. So I would rather use this equation on this one because I'm solving for V. So I write the equation down. I don't substitute. I write the equation first, then I substitute. And when I substitute, I'm just substituting my numbers. This is my distance, 100 meters. My time is 9.58 seconds over there. And then my velocity, wish I could get rid of that stupid bar. Why does that bar keep popping up? And then my velocity is going to be 100 divided by 9.58 gives me 10.44 meter per second. And you guys are like, well, I don't know how fast that is. It's around 25 miles an hour. That's like top speed for a human is around 25 miles per hour. Okay, make sure you solve it and add the units. That's the 5 step. Pretty easy. Diagram it, write the equation, substitute, solve, and add units. We do that all day long. So the second part of the warm-up question is, if you ran at this speed for 2,500 kilometers, how long would it take? So I got my knowns and unknowns from above, but I'm going to add one. I'm going to add, I know how fast he's running now, which is 10.44. I could use this equation, and I want to get t by itself, or I could just substitute directly in and solve for t. I've shown you how to do that last class anyway. So this is just kind of a repeat, but just really solidifying the idea that we're doing the 5 steps to a physics solution. So in this case, I'm going to multiply t on each side, and then I'm going to divide by v, and it's just basically cross multiplication. And so this turns into this. V equals delta x over t turns into t equals delta x over v. I substitute my distance over my velocity this time, and I get my time. I divide that time by 60 seconds because it is in seconds, and it's 4 minutes, bro. 4 minutes. That's pretty fast. I guess if you're driving your car at 25 miles an hour and there are no stoplights and no stop signs, 4 minutes, spell error, that's possible. And that's the end of those notes. That's going to lead us into this exercise, which is called Sparky Quiz. Now, I don't care what order you do it in, to be honest. This is not like in order. I don't really care what order you do it in, so I'm going to go right to the Sparky Quiz. So on the Sparky Quiz, when you go there, we're doing 1.3. We already did 1.1 and 1.2. We're doing 1.3. It's called the 5 steps quiz. And it reminds you, hey, these are the 5 steps. I don't need to, why is that colored? Don't be colored. Stop it. There we go. No, write your diagram, write your equation, substitute, solve, and use units. And then these notes are directly used on question 1 and 2 on the quiz. So if I go to question 1 and 2 in the quiz, I want to see a snail with a rocket on top. And he's going to, like, this is legit snail speed, by the way. This is real snail speed. If you ever want to know how fast a snail goes, this is it. I looked it up online, right? Let's do some research. So a garden snail takes about 80 seconds to travel 1 meter. How fast is that? And then if Starbucks is 200 meters away, how long will it take the snail to get there? Yeah, I bet you were wondering that, weren't you? Okay, so I go back to the previous page where it has the introduction, and there's the snail notes, right? There's 5 steps. I draw it, I write the equation, I substitute, I solve, and a snail goes really slow. And so that number is so small, I decided to show you it in millimeters per second. So that's like that per second, 12 millimeters per second, not very fast. Okay, then the second one is about a Lamborghini, right? So Ferraris and Lamborghinis, my favorite cars. Lamborghini's probably my favorite. Anyway, that's the Aventador. And its top speed is 350, which is 217 miles per hour. That doesn't help us too much because we need meter per second. So here I'm going to show you how to change it to meter per second. So you're just kind of seeing, you don't have to do that a lot in class. I'm just showing you this. Technically, you don't have to take notes on that one because I'm just showing you how it works. So it's 97.22 meter per second. And now it says, how long would it take to get there in seconds to Arco Arena? Or what's the call? Now it's called Golden One Center. Maybe it's changed again, where they light the beam, right? So anyways, how long would it take to get there in Lamborghini if you had nothing between? Right? That's awesome question. And then convert it to minutes. So go back to this again, scroll down, 5 steps, right? I got my knowns and unknowns. I got my equation, right? But I'm solving for t this time. So I didn't rearrange it. I'm just going to solve for t, right? And then I solve for t. I get 370.29 seconds. How do you put that into minutes? How do you put that into minutes, right? You guys know how to put that in minutes, hopefully. So we go back to the quiz. We put that into seconds, and we also put that into minutes, right? Minutes divided by 60. Okay, then you're done with the notes, but you got to do your own now. There's 6 questions down here. Do the 5 steps and see if you can master these equations. Okay, do the 5 steps so you can master those equations. Now remember, if you're looking at it and you're seeing, what are these check marks for and stuff, right? So I got this check mark. That means it's all correct. I did it right. I get this weird looking check mark, which means probably the wrong units, right? It's not T, it's seconds. Careful with your units. It is case sensitive. And this X just says, hey, you wrong, bro. So you're wrong. All right. Now going back to the last 2 things. The gizmo, I'm going to give you I'm going to give a sub. I'm going to cut out some papers that's going to have your sign in, and you have your own. I'm going to log out maybe so I can show you. I'm going to log out. So I'm going to log out, and maybe you use Gizmos in another class. Maybe you haven't, but you have to have your own account, right? So I got my account. You got your account. It'll be linked to my classes, and it'll show up here. Okay. Why aren't you logging me in? There we go. And so this is what we're going to do. And on the instructions, it says, click show graph and show animation, and then click the green button, and then click new and repeat. So I'm going to show you the whole thing. Pretty easy. I'm going to click this, boom, and this, boom. And it's going to put the blue person on the graph. The red is the red person. The blue is the blue person. Hey, what do you think the people are going to do right now? So if I click the stopwatch, do you think that the red person is going to run at a constant speed and the blue person is just going to stand there? I don't know. Let's see. Come on. Oh, yeah. So that's what happened. All right, so I'm gonna restart that. I'm gonna go new. Now, who do you think's gonna win this race? Red or blue? Who's gonna win the race? Red or blue? Ready, set, go. Oh, red got him, right? Why'd red get him? Because red is faster. You see how this works? Click new. What the heck? Now who's going to win the race? Man, what, is red the faster runner? I don't think blue's even trying anymore. I think blue's just going to, just walk as slow as possible. Looks like he's running though. Try as many as you want. Try as many as you want. Different examples of what's going on. Okay. Then we go down here and see if we can answer the questions. This is multiple choice, so hopefully it's not too hard, right? I'm not trying to kill you on this. Check your answers. Do it again if you need to. Okay. This is all graph work. Okay, finally, man, this is a lot of work. Maybe the book work, I don't know. So bookwork. The bookwork is the last one. So you're going to go to, it says over here when it's due or whatever, and you click here, unit 1, linear motion. You click right there, boom. I might give you 2 days to do it, right? So I'll probably end up doing that, give you 2 days to finish it. So the first thing is, like, you look at your notes, and the note just says, what's the difference between velocity and speed? Well, velocity is displacement over time. It says right there. That's what this green is saying. And speed is distance over time, and they're slightly different. Now, what is the difference between displacement and distance, you ask? And so distance is how fast you actually go. So if I go 10 and 4, I've gone 14. The displacement is how far you are from the beginning. So if I start here and I end up there, I've only gone 6. So distance is the total distance, and displacement is how far you go from the beginning. We have talked about this in class before, I'm pretty sure. If you get these questions in this set, they're a pain. So come back in here and just see what jerks they're being. You can read this. That might help you if you get these 2 questions. Like if you get 2 questions, one is about a truck crossing a bridge, and the thing is something about rounding, and there being a giant pain about rounding, and I hate it when they do that. Like the rounding is such a pain. And this one is almost like a trick question. They give you this extra number and it's not even relevant, and it talks about scientific notation. Most of the questions aren't this hard. So if you get those 2, come back here and see what you're talking about, or take it again. And it's everybody, you don't get it every time. Like some people will get it and some people won't. So I just hope you don't get those 2 questions. But if you do, you might want to come back in here and look at it and see what they're doing. Those are like extremely harder than the rest of the questions. So, okay. So here are the questions. You go back to the folder and you click where it says the assignment, which looks like this. And it's reading. It's the book. It's the chapter in the book. You don't have to read the whole chapter. Maybe you're brilliant. If it were me, I'd just look real quick and then I'd give it a shot. I'd scroll down. If I felt like doing the animations, I'd do the animations if I felt like it. But really, I'm kind of the person, I want to see how I would do without even trying, without even reading. And that's totally fine, actually. The reading is to support you if you don't know what you're talking about, right? So I go down to review practice, right? And then I try the practice. Okay, so I'm going to try this practice. If I can, let me scroll down, right? And it's going to give me a bunch of questions, right? Tim walks the mailbox 600 meters south and do his neighbor's house 300 meters north. The entire trip takes him 5 minutes. Careful. What's his average velocity? So you could get this wrong. You'd be like, okay, I'm gonna do 600 south and 300 north, right? That's down 600 and up 300. So that's 300 over 5. And 300 over 5 seems like 60 meters per second. But that's 60 meters per minute, right? So if I check that, it's going to be like, oops. No thanks. I can do this on my own. If it's 60 meters per minute, then it might be a different answer, right? So, and you go through that, and maybe it's this one. So, let me try it. So next, let me try it again. It gives me a new question. And so when you go on through that, you got to submit it. It says turn it in or something like that. You got to submit it or turn it in. Okay. Next class, you are going to have a sub, and you'll do some stuff in class. So if we go to the next page, this is the sub day. You're going to have a math pretest. You're going to have a worksheet for the bicycle, and you're going to have an ed puzzle. So the work that you do on the previous day, If you find out that I gave you too much work to finish in one day, um, you know, you could finish it on this day because this day isn't super packed either. I don't know. Um, anyways, I'm not trying to kill you here. I'm just trying to give you some work to practice, some good practice while I'm gone. Anyway, that's what we're doing that day in class. And you can always email me if you have any questions. So have a great day and a great Labor Day weekend. And I will see you on like Tuesday or Wednesday, something like that. All right. All righty. Bye bye now.